September 2025. Okay, so under this paper, all the topics will be tested as per the examination guideline. Okay, and some of the topics basically that are covered in paper 2, we know that we're going to have statistics. Okay, statistics, sample cohort data handling. Okay, so usually it's 2 questions in that case, but overall the mark allocation should be plus minus 20 combined. Okay, whereby the first question normally talks about the ungrouped data. Okay, and then the second question talks about the bivariant type of data with the correlations and all those things. Then topic number 2 that we can think of in paper 2 is analytical geometry. Okay, so analytical geometry. Number 3, we have what we call the trigonometry. And then after the trigonometry, then we can have our Euclidean geometry. So basically, these 4 topics are the backbones of paper 2. Okay, so please just follow with me as we go over this paper together. Okay, so bit by bit, I'll try to be as brief as I can, but also explain some other details, okay, just when need arises. So let's use this as our sample paper. So in this case, we have 10 questions that we're gonna be dealing with, okay? And the first question is statistics, as always. First 2 questions will always be statistics. So they're telling us that a group of learners wrote a standardized mathematics test that was recorded out of 60 marks, okay? And then the results were represented within the table. So learners that got between 0 to 10, we have a cumulative. We don't know how many they are. 10 to 20 up until 60. So we've been given the cumulatives, and then 1.1 wants us to complete the table, meaning that we need to fill in the frequency column. And so what we can notice, or what we know, is that the first cumulative must always be the first frequency. Okay, and then for us to get the next frequency, we just have to do the subtraction. So 60 minus 20, which is a 14. Then 120 minus 60, which is going to give us a 60. Then 170 minus 120, that gives us 50. Then 190 minus 170, that's a 20. And then 200 minus 190, just 10. Okay, so these represent our frequency values. Okay, so 20, 40, 60, 50, 20, and 10. Now, if we want the total here, it should be equivalent to the last cumulative, which will be 200. So how many learners wrote the test? It's basically 200. So even without adding all of this, the last cumulative value should be able to give us that answer of ours. Now they want us to draw a cumulative frequency graph. Okay, I don't have that page, but I'll try to just put it down here, just for the purpose of people having an idea, okay? So with the intervals, we have 0 up to 60. So I can use 10. So 0, that's a 10, 20, a 30, a 40, a 50, and maybe a 60. And then I know the graph is a bit skewed, but just bear with me. Then the biggest frequency that I have is 200. 200. Let me use intervals of 20. Will 20 make sense? No. Let me use 50. And so that's a 50. That's gonna be 100, 150, and 200. Okay, so when you're plotting or when you're graphing a cumulative, we normally use the upper class intervals together with the cumulative frequency. So 10 is gonna go with the 20. Okay, 10, we know 20 could be somewhere there. And then 20 is gonna go with a 60. As per our cumulative, 60 should be slightly above 15. And then 30 is gonna go with a 120. So 120, just somewhere there. I want to believe so. And then 40 is gonna go with a 170. 170 is just slightly close to halfway the mark. Oops, why does it look like it's gonna be a straight line? Okay, then 50 is going with 190. So 50 is a 190, and then 60 becomes the 200. Okay, then connect this with your points with your freehand, and then you need to extend the graph to the mean. So the starting point, that's where the graph must start from. It needs to be footed. Okay. Okay, so that is the cumulative graph that we would have in that sort of scenario. Then how many learners scored at least 20 out of 60? So when they say at least, meaning that the minimum is 20, but the maximum can be 60. So what we do in that case? So we know that between 10 up to a maximum of 20, we have 60 learners. Okay, at that point, the cumulative of between 0 to up to 20 is 60, meaning that those that obtained either 20 or slightly above 20 out of 60 should be all these ones. Okay, so what I can do, I can just say my 200 minus 60, which gives me 140. Because even if I were to get it from the graph itself, okay, if I'm to read off the 20, I'm gonna get a 60 here. Okay, and then I have to subtract that from that, and then I get my answer. Then determine the mean estimate. So the mean for the group data, some people prefer to get the midpoint here and then create a table. Yes, it's allowed, but it's a bit lengthy. How do we get the midpoint? You add 0 plus 10 divided by 2, that's gonna be a 5. Then 10 plus 20 is a 30 divided by 2, that's a 15. This is going to be a 25. That's going to be a 35. That's going to be a 45. This is going to be a 55. Then this multiplied by the frequency, okay? Because we know that the estimated mean will be given as the summation of f of x over the summation of f, whereby we know that our f is already at 200. So the f of x is what we need to add up. So meaning if I get those midpoints together with the frequencies, remember the first one is a 5 multiplied by 20. Next one is a 15 with a 40. And then we have a 25. We're going to multiply it with 60. And then a 35 by 50. Then we're going to have a 45 multiplied by 45. We say it's going to be multiplied by 20. Okay. And then the 55 with 10. And then the answer we get, divide this by a total of 200. So I believe this is the easiest. Just determine your midpoints and represent them in this format. So when I plus up everything that is on the top, I'm getting 5.4. Divide by 200, and then we get an answer of 27. Please, you can cross-check with your calculator if I'm not telling lies. No? All right, so that is question number 1. Now, this question 1 could also come in terms of, let's say, the box and whiskers, the quartiles, the standard deviation, the mean, the mode, and all those other aspects. Okay, so let's just prepare and be ready for whatever might be brought. Question number 2. A group of 9 students attended a course in statistics, okay, on Saturdays of a period of 10 months. And then the number of Saturdays on which the student was absent was recorded below on the scatter plot was drawn, okay? So if the student was absent for no day, we get a 96%. For 1 day, it's a 91. So we literally saying that the more the absenteeism, the lower the marks. Okay, so they drew the box and they drew the scatter plot for us. And then they want us to determine the equation of least square regression. So what this question tests is basically, are you able to use a calculator? Okay, when you're punching these values. Remember, it's the mod, and then go look for 2VAR, okay? And then you start entering these numbers. So start with the first one, which will represent the X, and then this will represent the Y. Punch in all the numbers, and then you cancel out, you clear all, and then you go back and find whatever. So if I follow my calculator, I'm getting my A to be a 90,375. I think the next episode we should come with a live calculator and show how we're getting these answers. Okay, then now B is a negative 4,875. Okay, but the question wants the equation, meaning that our Y should be a 90,3. You can round it off to 2 decimals, okay, minus 4,88x. So that is the line that they want. And then for us to get the correlation coefficient, so remember this can also be obtained from the calculator. So my correlation is a negative 0,8. Okay, we can add a 0 since we want everything to be rounded to decimals. Then comment on the strength. So whenever you're commenting on the strength, number one, you need to talk about the weakness and the strength, meaning that is it weak? Is it strong? Is it moderate? And then from there, we need to go on and talk about the direction. Okay. Okay, so we're seeing that a 0,8 is really a strong correlation or relationship, okay? So what we can say, since it's a negative, we can say it's a negative strong correlation or relationship. Okay, so strong, negative, whichever way you want to put it, no problem. Then 2.4, if a student scored 52%, can we predict the number of days that the student was absent? Now, remember, the percentage is the Y, okay? X is the number of days that the learner was absent. So let's use our equation, okay? And say where there is Y, we're gonna say 52 is equal to 90,38 minus 4,88x. So start by moving the 90 to that side, okay? So it's gonna be 52 minus 90,38 is equivalent to negative 4,88x. Divide both sides by negative 4,88. I mean, this can be done just on the calculator without showing all these steps. So the answer we are getting is 7,86, but then predict the number of days. So since it's days that are countable, okay, so this is approximately 8 days. Okay, the learner was approximately absent for 8 days. But, okay, then is the answer calculated in 2.4 reliable? Okay. What would be our response in this case? The response would be that it's a yes. Okay. Why is it a yes? Because the correlation is negative. Okay. Because of the negative correlation, meaning that if you're absent for more days, even the possible mark for you that you obtain is basically smaller. We are seeing that for 7 days, the learner got a 56. Now we're saying if the learner is absent for 8 days, it should be a 52, which means it's following the trend, meaning that it is very reliable. All right, then we move on to question number 3, which is the analytical. In the diagram below, A is negative 26, B is 8, negative 4, C is negative 6K. Are 3 points in the Cartesian plane with M that is lying there. They are telling us that AM is the same as BM, meaning that this point is a midpoint. Ne? Let's baptize it there. Then also AB. Where is AB? All of this is the same as BC. So this is the same as that. Okay, then D is a point on the y-intercept of the line AB. Okay, thank you very much. Then they want us to get the coordinates of M. Now, since we say that M is the midpoint, meaning that we're going to need to use the midpoint formula. And that formula tells us that x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so n can be our x1, so just get -2 plus 8 divided by 2, and then 6 plus -4 divided by 2. When we simplify that, that's going to be a 6 over 2, which is a 3. Simplify this, a 2 over 2, which is a 1, meaning that M is basically 3 and 1. 3 and 1 will become our answer. And then 3.2, they want us to get the coordinates or the value of K. How many marks? 6 marks. 6 marks. What are we going to do? Are we going to use the distance formula? I think that's going to be the only reasonable thing, since they told us that AB is the same as BC. So we can get the distance of AB and then equate it to the distance. Won't this give us a quadratic? But there's nothing we can do since we're focusing on the 6 marks. So distance formula is going to be x2 minus x1 squared plus y2 minus y1. Everything is squared. Okay, when I do the substitution, that's going to be 8 minus minus 2, which is going to be like a 10 squared. And then -4 minus 6, which is also -10 squared. Okay, so that's 100 and 100, which gives us 200. Ne? And the root sign, which is the same as 10 root 2, not 2 root 10. It's 10 square root of 2 units. Ne? So that is our AB. Then we're going to equate this to the distance, since we already have our coordinates as 3, 1. Okay, so why don't I just write it on this other side? Okay, so we're saying that M is 3, 1. And then this point is -6K. Is that a C? Perfect. Okay, so we're saying that MC, but it's not MC. We're focusing on BC, 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 BC. What's our B? It's 8, -4. Okay, so BC, which is the same as AB, should be the same as, okay, we're going to have 8 minus 6 squared plus -4 minus K squared. You can arrange it in whichever way you find convenience. Okay. And then we said we're going to equate this to 10 square root of 10 square root of 2. Let's open up there. You're going to have 8 and 6, which is a 14. Is that a 14? Did I do anything wrong? Let's just erase this out and see. So this is 8 -4. Okay, so it's 8 -4 -6 and a K. Okay, when we do the substitutions, okay, when we do the substitutions, that's going to be 14 squared plus, that's going to be 16 plus, that's going to be 8K plus K squared. This must be equal to 10 square root of 2. Okay, I'm just opening this square bracket. Then I need to square both sides to get rid of the root sign. So 14 squared is going to be a 196 plus 16 plus 8K plus a K squared must give me 100 times 2, which is 200. Let's move everything to one side so that we have a K squared plus 8k. Okay. Then that's going to be a -4 plus this. I think it's just going to be a 12. Né? Because I'm trying to look at 200. I'm taking away 196, which is a 4. Okay. 16 minus 4, which gives me a 12, is equal to 0. And then I need to factorize this. The two numbers of interest will be 6 and 2. So k plus 6, k plus 2. So either k is a -6 or k is a -2. K is a -6, k is a -2. So we need to confirm and see. We know that this y value is a -4 here. There is no way this k can be -2 below the -4, meaning that our k needs to be a -6. It cannot be this -2. All right, so we've decided and we got those 5 marks, then hence or otherwise they want us to get the equation of Cm if k is a -6. Thank you for confirming that. Okay, the equation, so we saw that C is that M is 3 and 1. Okay, M is 3 and 1, and then C is -6 and -6. Okay. Okay, so they want the equation. So whenever we get the equation, number 1, we need to find the gradient, okay, change in y over the change in x. So we're going to say 1 minus -6 over 3 minus -6. Meaning that we're going to have a 7 over 9. Okay, that's the gradient. Yeah, I know it's weird, but it's fine. Then let's use this point. Okay, some people prefer to use the mx plus c. They look for the c. I prefer to use y minus y1 is equal to m into x minus x1. I'm going to use the point m. So it's saying y minus 1 is equal to our m, which is 7 over 9 into x minus 3. We open this up. So 7 over 9x minus, that's going to be a 21 over 9 plus 1. Okay, simplify this fraction, 7 over 9x. When I simplify this, it's supposed to be a 7 over 3. Means that's -7 plus 3 over 3, which is a -4 over 3. So this is what I get as my equation. All right, we move on. If A, E, B, C, if A, B, no, if A, E, B, C, A, E, meaning, before I even finish the question, trying to look for point E, I'll just locate it to be somewhere there. I don't know. A, E, B, C is a parallelogram, and K is -6. Determine the coordinates of E. So if this is our E, I'll just put XY. Okay, we have that. And then we have that. Don't mind about the shape, but we just focusing on the parallelogram part. How many marks is it? It's 2 marks. Okay. So if it is 2 marks, and we already know that our AB is a diagonal, meaning that this point M is going to be a midpoint even to this AE. Now, if this is x, this is a -6, we're going to have something like -6 plus x divided by 2 must give us a 3. Okay, cross multiply, meaning that -6 plus x is equal to a 6. Move the 6 that side, x becomes a 12. We do the same with the y. If we get k, which is a -6, plus the y value of E, divide by 2, we must get the y value here, which is a 1. Cross multiply, -6 plus y is a 2. Then y becomes 8. Okay, so that's what they wanted. I don't know why they are giving us just 2 marks. Okay, 3.5. Given that the straight line given that a straight line is defined by this. They want us to determine the value of m if the line has an inclination of this, like y. Because I don't see any big logic in this. You know why? Because we have the inclination here. But then they're telling us that if a straight line defined by this, determine the value of m if it has an angle of inclination of this much. Okay, so what I'm going to do, let me start by maybe creating a standard equation, okay? 2y minus 1, okay, 2y minus 1 is equal to mx. Let's leave y on one side. So y is going to be a half m of x plus 1 over 2. So move this one that side, it will be mx plus 1. Okay, then divide through by 2. We shall get to this. What does this mean? We need the value of m. But we know that this m is the same as m over 2 times x. So this is like the gradient of interest. We know that tan of theta is equal to the gradient. Okay, just the normal gradient m. So we're going to say if we get the tan of 116,56, we should be able to get to our gradient. So punching this into the calculator, we're getting a -4. Then this is just the value m, but then this m over 2 is our gradient, means that -4 divided by 2, the answer becomes a -2. But what was the question asking for? Determine the value of m. So I'm not sure, because if the question was asking for the gradient, then I would have gone for the -2. But if they're asking for m, then this would make a lot of sense. I don't know. Let's see what you guys have to say about that. Then calculate the coordinates of D. Where is D? We don't have D. Did they mention anything about D? So they told us this is the y-intercept. Oh, it's here. Okay, so how do we get those coordinates? How many marks? It's 2 marks. Do we need to get the equation of the, okay, we're saying that the gradient is -2. But this is a y-intercept, meaning that the x is going to be a 0. Is there anything special they mention about D? There's nothing. It's just y-intercept of AB. So 2 marks is still an understatement, unless if there's something that I'm missing for 2 marks. For 2 marks. Okay, the equation, we know we only found the distance. Did we find the gradient? Nothing, we only found the midpoint. Okay, so let's try to find the gradient of AB. Maybe that will lead us to what we want. So it's going to be 6 minus -4 over -2 minus 8. That gives us 10 over -10, which is a -1. Let me use 3 and 1 and say that y minus 1 is equal to -1 into x minus 3. So y becomes a -x plus 4. Okay, so this is our equation, and the y-intercept is 4, meaning that D is going to be just 4 with a 0. So 0 and 4 becomes the D. Then they want us to get the size of B. The size of B. Now, is the B in relation to the triangle or the parallelogram? Okay, I'm just going to ignore the parallelogram and focus on the triangle here. Okay, so this angle here is what the question is asking for. So It should be a lot of marks, né? It's 5 marks. What do you think needs to be done here? What needs to be done? You see the gradient here is a -1. We got the equation of MC. And what was the equation of MC? We got the gradient to be 7/9 for MC. For us to get this, do we need to extend this line? I think that's the only logical explanation that I'm seeing now. Let me just take this out so that I can show people what I'm seeing so that I don't waste a lot of time. Okay, so what I'm saying, I'll just extend this and then extend this line. Okay. So I'm gonna treat this as my exterior angle. Let me call it theta. I'm gonna call this a beta, my angle of inclination. And then let me call this my alpha, also the angle of inclination. So that when I plus these two, I should be able to get to the theta. Now, since we say the gradient here is -1, I'll say that the shift tan of -1 is to give me alpha. And I know this is going to be like a -45. Okay, so if that's -45, technically I know that this will be the 45 and this one will also be the 45. Then what is the gradient of BC? I think that's the only tricky part. Let's look for it. BC is going to be -4 minus 6 over 8 minus 6. Okay, so when we plus this up, we're gonna have a +2 over 14, which gives us just a 1/7. Okay, so that's what I'm getting as my value. So I need to get the inclination value. Okay, let's punch this into our calculator and see. So we're going to say that the shift tan of 1/7 should give us our beta. Shift tan of 1/7 because I'm focusing on this line. Okay, so shift tan. Nope, that's not true. It's saying the shift tan. Okay, of 1/7. It's giving me a very weird answer. Very weird answer. I'm getting 8,13 as my answer. Okay. I don't know if it's my calculator, but that's what I'm getting. Then if this is 8,13, meaning that I just need to plus these two and get my value of B. So 45 plus 8,13, that gives me 50, what? That a 53,13 degrees. Okay, so guys, that is if I'm using the triangle part. But there are also other ways, okay? We shouldn't just focus on that. Remember, we found the distance, this one to be 10 square root of 2. This is a 10 square root of 2. You can even find this distance, okay? And then we use the cosine rule. That is also one other quick way to get the answer. Okay, so nevertheless, it's all about the approach that we are interested in, for as long as you get an idea of how to go about this. So cosine rule could also be applied in this case. There is no problem with that. All right, so someone is saying there's an issue with our gradient for AB. Is it not -1? So you say 6 minus -4 over -2 minus 8. It's a -1, okay? So I believe even if you use the cosine rule, we should be able to get the same answer. Then determine the area of the triangle ABC. So I'm going to use this angle that I found, okay? I'm going to use 53,13. So we know that area of a triangle will be given as a half AB sine of C. But now since we have angle B, okay, it's just gonna be a half times A times C, the sine of B, okay? So that's a half times 10 root 2 times 10 root 2, the sine of 53,13. So I'm just using the angle that I got, okay? So if ever you get a different angle, is just use the same steps and then use that same angle that you got. So when I punch this into the calculator, that's gonna be the sine of 53,13. Okay. I'm multiplying it by 100. It's giving me, because this and this is gonna be 200 divided by 2, that's like 100. So I'm getting 79,9998, which is approximately 80 units squared. All right, so that is how we would have gone about with that, okay? Alternatively, if you feel there is a 90-degree somewhere, then go ahead and use it and find the distance. Okay, that is question number 3, 29 marks. Question number 4, which is also analytical, but this focuses more on the circle geometry. In the figure below, circle A has this equation. Line BC is a tangent at D. That's the point. Okay, everything is included. Determine the coordinates of A, which will be the center for 4 marks. So in this case, we need to complete the squares. So it's going to be x squared plus y squared plus 6x. Let's bring everything that side, plus 6y. Is equal to -1. Okay. So when you look at the x's, it's just x squared and 6x. Same story with the y squared and 6y. So how do we complete the squares in this case? So we can see that one value is negative, the other is a positive. Oh, I'm missing something here. This is supposed to be -6y. Sorry about that. Okay, so open the brackets, we square that, open the brackets, we square that, that's a -1. So I'll put my x there, I'll put my y there. What is a half of 6? It's going to be a 3. Keep the sign plus. And then I'll plus a 3 squared. And then half of 6 is a 3. Keep the sign to negative. And then we said I'll plus a 3 squared. Meaning that the general equation is x plus 3 squared plus y minus 3 squared is equivalent to, that's a 9. That's 18 minus 1, which is a 17. All right, so these are our center points. They are not interested in the radius, they are only interested in the center point. So we're saying A is going to be a -3 for x, a +3 for y. Perfect. Then they were asking for the radius of the circle, which is just going to be the square root of 17, because this represents r squared. So if r squared is 17, which means r alone will be the square root of 17. All right, then determine the equation of the tangent. Okay, so if this is a -3 and a 3, we need to draw that sort of a line. We know that tan radius will be perpendicular, okay? we know the coordinates of D to be negative 28 over 5 and then 31 over 5, okay? So let's get the gradient and then multiply it by -1, and then we get our answer. Okay, so gradient of the radius, we're saying is a 31 over 5 minus 3 over negative 28 over 5, we shall say plus 3. Okay, so when you punch all this in the calculator, we end up with a negative 16 over 13, meaning that the gradient of the tangent is just the reciprocal of this, which is a 13 over 16. Do we have a point that we're using? Because they want the equation. So we can use the same point, the 28 and so on. Meaning that it's going to be y minus 35, no, it's a 31 over 5 is equal to 13 over 16 into x minus minus, which is a plus 28 over 5. Open the brackets and collect the like terms. I don't know why this paper, they used fractions too much, but not a problem. Okay, so I'm getting the C as a 43 over 4, meaning that the equation is going to be 13 over 16x plus a 43 over 4. So that is what we get. Then they want the area of BCO. B, C, and O. Okay, so what this asks for us, we need the coordinates of C, we need the coordinates of A, which are basically the intercepts, okay? So meaning if X is a 0, Y is going to be a 43 over 4. If Y is a 0, okay, we're going to get X to be a negative 172 over 13. Then substitute that into the equation of the area of a triangle, it's a half, 172 over 13. The height, we said 43 over 4. Simplify that. You can give your answers in decimals, but I prefer to leave them as fractions. So it's going to be 1849 divided by 26, that's units squared. Then 4.5, the circle with this equation is reflected about the line y is equal to 0. And which line is that where y is 0? So that is the x-axis. Okay, so this circle is reflected about the x-axis. Can we write the equation of the new circle? So if it's reflected about the x-axis, meaning that it's only, okay, so we're keeping the x. It's only the sign on the y that's going to change. So the new coordinates of the center will be -3 and a -3. Okay, so the new equation, I prefer to write it in a simplified version. It's going to be x plus 3 squared, and then y plus 3 squared is equal to 17. Nothing is going to change. That has to be the equation. And then hence, calculate the length of the common chord of the two circles. Write your answer in simplest form. So if we have the same circle reflected, meaning that the two would be, no, that is a lie. That is a lie. So if that is our center there, this is our center. So we can have something like that. So the common chord, this one, is what they're asking for, the line that connects the two meeting points. So you need to equate the two equations and solve them simultaneously because that chord is along the x-axis. Okay, sorry, yeah, along the x-axis where y is a 0. So with the first equation, if your y is a 0, your y is a 0, meaning that x squared plus 6x plus 1 gives you a 0. Okay, When you punch this into your calculator, using the quadratic formula, obviously, né? We're going to get our x to be something weird. We have -3 minus 2 square root of 2, or x is a -3 plus 2 square root of 2. So we already have the 2 points, this one and that one. Then we just need to get the distance between the two answers, okay? So I'll start with a -3 plus 2 root 2 minus the smallest value, -3 minus 2 square root of 2. So this gives me 4 square root 2 units. Okay, so I've used just one circle, but you could also use the other circle. Alternatively, you can solve the two simultaneously, whichever way makes you get the marks. Question 5, which is the trig. Okay, they're telling us we are given the cos of A being this compound angle formula or identity. Use the identity for cos A minus B to derive one for sine. So this thing is quite easy. The only thing you have to do is, how do I obtain a sine A minus B from a cos? So it's all about using a 90 formula or the complementaries. So I'll say A minus B is going to be the same as the cos of 90 plus A minus B, something like this. Okay, is it a minus or a plus? I think it has to be a minus, no? For it to make more sense. Because if I have it this way, then I'm going to get a negative. So meaning I have to use a negative so that I end up with a positive. Perfect. Then I'm going to snatch this A and keep it to the 90 so that I have the cos of 90 minus A and then minus B, something like that. And then I can open this using this identity that I was given. So I have a cos of 90 minus A and then the cos of B. And then I'm going to have a plus sine of 90 minus A and then the sine of B. So cos of 90 minus from our complementary reductions, that's going to give us a positive sine of A and then the cos of B, plus the sine of 90 minus gives us a cos of A, and then that is the sine of B. So that is what the question wanted. So the trick is just with the 90, and then you merge this A together with that 90. Okay, then on 5.2, if sine of theta is this, and cos theta is greater than 0, calculate without a calculator and with the aid of a diagram. So this is the Cartesian. It has been simplified for us. We can see that sine is negative, when cos is positive. So we need to find the quadrant. Okay, so the cast, and we are saying the sine is negative in quadrant 3 and 4, but cos is positive in quadrant 4. So meaning that our sketch needs to be somewhere here. Okay, that's the 19. They told us 12 over 13. So this is the 13. This is the 12, which is a negative. Then use your Pythagoras to find the missing side. Okay, so when we do that, so it's going to be like 13 squared minus 12 squared under root sine, which gives us a 5, ne? Positive 5. So remember, the hypotenuse is always positive, cannot be negative. They want us to find the sine 2 theta. So this is the same as 2 sine of theta, cos of theta. Let's now substitute. So it's going to be 2 times the sine is negative 12 over 13. The cos is 5 over 13. So this is a 10. So it's a negative 120 over 169. That is what I'm getting as my answer for 5.2.1. Then cos of theta plus 30, this is a compound angle. We just need to open it up. 30 is a special angle. So it's going to be cos of theta cos of 30 minus sine of theta, sine of 30. Okay, let's use just a different color. So cos of theta is going to be adjacent, which is 5 over 13. The cos of 30 is going to be a root 3 over 2, if I'm not mistaken. Then we are subtracting the sine. They gave us negative 12 over 13. And then the sine of 30 is a half. Remember, they said without a calculator. But can really this one be simplified without a calculator? That's like being unfair. But anyway, we can do it because denominators are the same. So I'll have a 26. So it's a 5 root 3 plus a 12. That should be our answer. Don't give us decimals, otherwise they'll get you there. Evaluate again without a calculator. So cos of 35, sine of 35, we have 225, we have 200. Let me write it this side. Okay, so it's saying sine of 35, cos of 35, tan of 225, and then cos of 200. Okay, so these ones, I believe they are shorting something to give us the double angle. And that is basically the half that I can introduce. Then 225 is a special angle, which is more like 180 plus 45. We can find it on the in the Cartesian. 200 is 180 plus a 20, which is in the third quadrant. Okay, so I'll start by saying it's a half sine of 70, because 2 times 35 is 70, over, we said 180 plus 45 gives us the 225, that's quadrant 3. It's the same as the tan of 45. And then this one, cos is in the third quadrant, cos is negative. Cos, so it's a negative cos 20. Then we know that sine of 70 is the same as the 90 minus 20, which gives us a cos. So it's going to be a half multiplied by the cos of 20 over tan of 45 is a 1, and then negative cos of 20. So this cancels that, which means our answer is just negative a half. I don't know. I believe that's what I would have done to get those sweet 5 marks. Okay, then they want us to get 1 minus sine squared of 22,5. So we know that 22,5 is just the half angle of 45. Okay, so how do we express this? We can say that 1 minus, let's change this to a cos. It's going to be 1 minus cos squared of 22,5. The 1 and the 1, they're going to cancel out. And then we're going to be just left with the cos squared of 22,5. They want us to get the value of this. Okay, so I'm going to go back to the double angle and half angle. Okay, so we have cos squared of 22,5. But we know that cos 2 of 22,5 gives us a 45, meaning that we, as well as dealing with the cos of 45. So the double angle of cos that has cos squared, what is it going to look like? Did we do the right thing here? We said 1 minus. Isn't that wrong? Because we said sine squared is the same as 1 minus. And then that is cos squared. It's fine. It's okay. It's okay. It's okay. Meaning that we have 2 cos squared of 22,5 minus 1. this needs to be the cos of 45. Okay, the question is asking for the cos of what? They're asking for the value of this. So I'm going to move this one that side. So it's a cos of 45 plus 1 divided by 2. So cos of 45 is 1 over root 2, or root 2 over 2 plus 1 divided by 2. Can simplify this further, which will give you root 2 plus 2 over 4. That becomes our final answer. All right, 5.4, we have 3 sine p plus 4 cos q is equal to 6. 4 sine q plus 3 cos p equals to 1. Can we prove that the sine of p plus q is a half? 6 marks. What are you going to do there? Okay, so what I'm going to do, because it's a bit tricky, né? I'm going to start by squaring here, and also squaring this side, because that's the only way to sort this out. So I'm going to get 9 sine squared p plus 24 sine p cos q plus 16 cos squared q is equal to 36. Let me do the same there. I'm going to get 16 sine squared q plus 24 sine q cos p plus 9 cos squared p is equal to 1. That is equation number 2. Then I'm going to plus the two equations together and see if I can get some like terms. Are there any like terms really? Okay, so cos squared q, sine squared q, there seems to be no like terms. Let's see. 9 sine squared p. Okay, this is different because it's a sine q and then a cos p. Is there anything common? So if I get the 9 and the 9, will that make sense? Let's say when I'm doing the addition. So it's a sine squared p plus cos squared p. Oh, this and that. Let's do the same with the 16. 16 cos squared q plus sine squared q. And then these ones, I mean, they have the same 24. And then we have sine p cos q plus sine q cos p. This is equivalent to just a 37. Okay, so we know that sine squared cos squared is a 1. That's a 1. Means a 9 plus 16 plus, this is now going to give us a compound. Sine p cos q is the same as now 24. Sine of p plus q is equal to 37. Okay, we know that 9 and 16 is a 25. Let's move everything that side. So 24 sine of p plus q is equal to, so 37 minus 25 gives us just a 12. And then divide both sides by 24. Being that the sine of p plus q gives us a half. Yo. This is dangerous, ne? If it's further given that PQR are interior angles of a triangle, R is acute, they want us to get the size of R. Okay, now we know that P plus Q is equal to a half, meaning that if we can get, is it gonna make sense if we have to look at it that way? because we know that P plus Q plus R must give us 180 degrees, meaning that if we can get R, it's going to be 180 minus the sum of P plus Q, minus the sum of. Alternatively, we can just have P plus Q being 180 minus R. Either way, so I prefer to use the latter, okay? Meaning that I can use this here. So the sign of 180 minus R is equal to a half. Then the shift sign of a half gives us 180 minus R. Does that make sense though? Does that make sense? If we reduce, because we cannot just say that is 180 minus R. Oh, that would be a lie. Okay, so this is going to be just sine of R is equal to a half. And then shift a sine of a half is going to be just a 30 degrees. Yeah, that would make sense. All right, question 6, the trig graphs. Okay, f of x is that, g of x is that. Between that domain, determine the value of q if f touches the x-axis at the origin. What is q? Q is the shift of the cos graph. So if it's a -1, which means, wait a minute, we're focusing on f. Find the value of q if f touches the x-axis at the origin. Is there a number before that? No. So we know that originally the graph is just supposed to pass through 1 and then up until -1. But now it has been dropped down. It's been dropped down. So y or q is going to be a -1. The graph has been shifted 1 unit down. Okay. Then the amplitude of f. Okay. So amplitude is going to be 1 because the maximum displacement, because the maximum minus minimum divided by 2. Then the value of b, if the period of g is half the period of f. So what is the period of g? The period of g is 360. The period of f is also, no. If that's 360, then it's going to be 180, which means b is a 2. Okay, so it's like 360 divided by 180, it's going to be a 2. Then the coordinates of the x-intercepts of g, where is g? This is g. So we already have now the equation to say cos 2x. Where do we find the y to be? A 0. So the shift cos of 0 is going to be a 90. Then, so 2x is a 90, meaning that x needs to be a 45. So that's a 45, and then that needs to be a -45. But the question is asking for the coordinates. So it's -45 and 0, and then we're going to have 45 and 0. Then use the graphs to determine the values of x in this interval for which x times the gradient to be negative. Okay, so when you look at the negative side, I think it satisfies all the values. Okay, meaning that there's a -90 is less or equal to x less than 0, or we can have 0 less x less or equal to 90. As x, so x is negative, the graph or the gradient is positive for f, which is on this side. Okay, and then when f is positive, the other one must be negative. So that is either sides of the domain. Question number 7, which is the 3D trig. They are telling us that a telephone cable is to be created between two cliff sides, AED and BE. An engineer stands at a point C in the same horizontal plane as the foot. All right. Then they are telling us to show that the length of the cable is given by that. So the cable is created between two cliffs, AD and BE. So this is our cable. I want to believe so. Is that what they say? They didn't even tell us which side they are focusing on. But that is the DE, that's the cable of interest. Okay, so they want us to get the length. How many marks is it? So it must have a tan theta and a sine alpha. It's some sense here to find that. And then the sine, I'm gonna find that distance. And then from there, we can use the sine also. Okay, so let's start with this one. So from triangle DEF, we're saying that the tan of alpha, should I use the tan? Yeah, it's given as the adjacent, but we don't know what DF is. Okay, so tan is going to be a bit weird. That would be my last triangle, maybe. Let me start from BEC. So he's saying that the tan of theta is the opposite, which is EB over the X, meaning that EB is X tan of theta. Then I can now proceed and use the sign and say that the sine of alpha is going to be the opposite, which is EF over DE. But we want the DE, which is going to be the EF over the sine of alpha. Now, for us to get the the EF, we need to get the EB minus the FB. Okay. They told us that this is a Y, meaning that this is a Y here, which makes life easy now. So it's going to be X tan of theta minus the FB, which is a Y. So let's punch that to the top, meaning that we're going to have X tan of theta minus Y over the sine of alpha. Oh, that was a quick 5 marks. Then if X is that, Y is that, and theta alpha 45, what's the distance between the cliffs? So we can use because they want the distance AB. Is that true? No, not AB. Yeah, it's the same as AB because they are focusing on DF, this distance. But we already have our DF. Is there anything that combines DF here? No, we didn't look at it. But it's fine. Let's do the substitution and find DF. But we're going to use DF, DE, because we now have our Y, we have the missing parts, and we can do just the substitution. So I would prefer to use the tan alpha, which is EF over DF, and then make DF the subject, which is going to be the EF over tan alpha. And we found our EF to be X tan this minus Y, okay? We say tan alpha minus Y. We are dividing it by the tan alpha. Let's do the substitution. So 1,000 tan of 45 minus 250 divided by the tan of 45. So this gives me 750 millimeters. Okay, so that is what we would have done with that. Question number 8, which is the Euclidean. Okay, so in the diagram, AD is a triangle that is having BC parallel to ED and AE parallel to that. It's also given that AB to BE is 1:3. Okay. And then AC is 3 units, EF is 6 units, and then CG is X units. They want us to get the length of CD. So these are parallel lines, okay? If they are parallel lines, then basically we must follow the same proportions, okay? So what we say is that if CD divided by CA should be the same as BE divided by AB. Reason is going to be the proportionality theorem because BC is parallel to ED. So we're saying that if our CD divided by 3 should be equivalent to 3/1. Cross multiply, CD becomes 9 units. Okay. Then they want us to get the value of X. Okay, this X here. So which lines are we focusing on? We can focus on this other section of parallel lines, these ones. Okay, because we said the whole of this is 9. If that is X, then this is gonna be 9 minus X. I don't know. Yes, that's what I'm seeing. Okay, so the whole of that is 9. So we're gonna focus on this over that whole part. So we still use the same proportionality theorem. So we're going to say if we have GD divided by the total distance, which is AD, this should give us the same as DF over the entire distance, which is ED. We're going to still use the same proportionality theorem. GF is parallel to AE. So let's substitute that, and we have our 9 minus X over the total distance, which is 12, is equal to 3/9. Cross multiply, and let's see what we get. So that's going to be, why must I multiply? So that's going to be like a 36/9, which is a 4. Okay, so meaning it's going to be 9 minus X is a 4, which means X is 5 units. Then they want us to get the length of BC. Okay, this length here. So one thing we need to do is just try to compare the sides. Okay, compare the triangles. So if this is a 1, and then this is 4 units, this is 3, and then that is what? That is 12. So we can see that the ratios are the same, 1/4, 1/4. Okay, so we can say that AB over AE. So AB over AE is equivalent to AC over AD, AC over AE, which must also be the same as BC over ED. BC over ED. This is going to be sides in proportion because the triangles are similar, okay? So that is one approach. Alternatively, one would start by proving that the triangles are similar. So we are saying it's 1/4 because the marks are really too much. Okay, so if we have 1/4, okay, it's equivalent to BC divided by, we know that this is a 6, this is a 3, which is a 9, meaning that our BC is going to be 9/4, which is 2,25 units. Then 8.4, the area of ABC, FD. Okay, be this one 4 times 3 over 3 times 4, meaning that we have 9/16. All right, question number 9. They want us to prove angle N. Let's call it N. Okay, so even this one, we can call it a 2 if we so wish. Then go on and tell us that number 1, we know that T1 and T2, T1 plus T2 is a 90. The reason, they turn perpendicular to the radius. Or you can tell us that will it be angles in a semicircle? Now it doesn't make sense for angles to be the same. I would prefer the tan radius, T1 and T2. That makes sense. Then S1 and S2 is the one that's gonna be angle in a semicircle. Angle in a semicircle. So if that is true, meaning that S1, okay, is going to be the same as T1. How is that possible? Because that's a 90 and 90, meaning that our T2 is gonna be 90 minus T1. Okay, and then when you look at S1, it's gonna be 90 minus S2. But we know that S2 is the same as, is it S2? Yes, S2 is the same as T2. And if S2 is the same as T2, therefore S1 is the same as T1. I think that is just enough for that particular part. Just that. Yo. Okay, question number 10, which is the last one. We get out of here. Okay, they're telling us that in a diagram, M is the center of the circle, and the diameter AB is produced to C. M is drawn perpendicular to AC, and then that is a tangent. Okay. Then, if that is a chord intersecting that, MB is twice BC. If D4 is X, okay, our D4 is X, they want us two other angles that are equal to X. Okay, so this is a tangent, this is that, so meaning that the angle A is going to be X. Okay, so A is X, we're gonna say it's a tan chord. And then, which other information were we given? Nothing, okay. So we're calling this X. If that is X, which means even D2 is going to be X. Angles that are opposite equal sides, because this is a radius, this is also a radius. If that is true, do we have any other X? I think that's all. That's all. Then can we prove that CM is a tangent at M to a circle passing through MED? MED. So for us to prove that something is a tangent, it's always the tan chord that must play the role. Okay, that is just one. Two, even the perpendicular can also help us in deciding that. So what we can start with is that if this is X, meaning that M1 is going to be twice X, exterior angle of a triangle. Okay, exterior angle of a triangle. Then from there, we could go on and say that our M2, this M2 here, is going to be a 90 minus the 2x. Okay, 90 minus the 2x. And we can say that that's basically tan radius. Okay, because this is a radius. Oop, does that even make sense? No, that can't be a reason. That could be probably the last part. We can say adjacent supplementary angles, because this is a straight line, this is a 90, all of that would be a 90, that's a 2x, okay? Then if that is a 90 minus 2x, okay, we know that this angle is going to be a 90, because definitely those are angles on angles in a semicircle. So if that is true, then where is our E? This angle here is going to be 2x. Because when you focus on the triangle MED, If this is a 90 minus 2x, which means this is 2x. And this 2x is the same as the 2x that we found there. Okay, so since E is the same as M1, therefore CM is a tangent. And the reason is going to be the converse of the tan chord. Okay, so that is how we would have proved that. Then can we prove that FMBD is a cyclic chord? Okay. So number one, we can start with the D3 and D4, or D3 and D2. I think that would be better. D3 and D2 to give us the 90. Okay. So we're saying D3 and D4. Let me just write it somewhere here. So D3 plus D4 is going to be a 90 angle in a semicircle. Okay, remember our target is FMBD. Okay, FMBD. So that's a 90. Then we also know that M1 plus M2 is a 90. Okay, so what does that mean? I want to use just the exterior, the opposite angles, okay, being supplementary. So we say adjacent supplementary angles. So therefore, FMBD is a cyclic chord. Reason being, opposite angles are supplementary. So the converse of opposite angles being supplementary. So this is a 90, and that's a 90. Alternatively, you could say this is a 90, and then M3 is a 90, and then you use the property of the exterior angles. Either way, okay? Then prove that DC squared is the same as 5BC. Okay. So what you need to do in this case, let me just erase this part here so that I can write it where people can see. I see. Okay, so we're going to focus on triangle DBC and DFM. Okay, so DBC as well as DFM. So we say that B1 is the same as F2 because of exterior angle of a cyclic chord. Okay, why can't I remove all of this? So DBC and DFM. Okay, so we're saying B1 is going to be the same as F2 because of the exterior angle of the cyclic chord. We agree with that. Then D4 is the same as D2. We proved that earlier on, that everything was X. Then we know, wait a minute, am I answering the correct? No, I'm answering 10.5, which is incorrect. It's fine. Let's finish with the 10.5, then we can go back, okay? Then lastly, so those are two, which means the other one is just going to be the third angle, means C is supposed to be M2, which is the remaining angle. So therefore, DBC is similar to DFM. Okay, so to prove that this squared is the same as that, we're going to need to use some bit of Pythagoras here, okay? So if I use triangle MDC, okay, because that is the triangle that's going to lead me to what I need. This is MDC, this entire triangle here, okay? I know that the whole of this is a 90. We saw that, no? The tan radius. Okay, so if that is true, then I can come down and say that my MC squared should be the same as the MD squared plus the DC squared. The reason that is basically the Pythagoras. Then what is our MC? They told us it is twice of they said MB is twice BC. Okay, so if this is a K, this must also be a K, so it's twice, so it's the same thing, meaning that my MC, wait a minute, MB alone is twice BC. If this is a K, this is gonna be twice K. That's the meaning, eh? So we're gonna have 3 BC squared. Our MB is this, which is twice BC squared. Okay, because this is a radius and this is also a radius, so they have to be the same. Then our DC, we can keep it because it's part of our solution. Then this is gonna be a 9 BC squared is equal to 4 BC squared plus DC squared. Let's move everything that side. So it's gonna be 5 BC squared, meaning that DC squared is 5 BC squared. Okay, that's fine. And then lastly, we proved that the triangles are similar. So this should be just a walk in the park. So you can say that DM over FM should be the same as DC over BC. Remember, we already proved that the triangles are similar. So if we do that, the reason is going to be similar triangles. So when you do your substitution, you're going to have root 5 of BC over BC, which gives us